All right, so on 19, we are given tangent's value, and then we're told that sine is less than 0. Okay, less than 0, that means negative, right? Okay, we want to find cosine. Look over here, tangent is also negative. So what quadrant is both tangent and sine negative? That's what we have to answer first, so we know what quadrant we're in. If it helps you to sketch out a little thing and do our little memory trick, you can do this. You don't have to. Some of you will know it. Okay, this is what's positive. All of them are positive. Sine, tangent, cosine. Okay, so I want to know, where is tangent negative? Well, it's positive here and here, so it's negative here and here. Okay, and then where is sine negative? Well, it's positive in 1 and 2, so it's negative in 3 and 4. So the overlap where both of those things are true is happening in quadrant 4. Is everybody okay with how we're figuring out our quadrant? Okay, so I have a triangle in quadrant 4. Now, the ratio that they gave me was tangent. What is the ratio for tangent? What over what? So if you're using O, A, and H, it's opposite over adjacent. What if you're using X, Y, and R? Y over X. I don't care if you think of it as Y over X or O over A. Either one's fine as long as you know how to label your triangle. Okay, so using X, Y, and R, like this is the X value, the horizontal movement. This is the Y value, the vertical movement. And this is R. This would be the radius if this was a point on a circle centered at the origin. Okay, if there was a big circle on there. Okay, if you're using OA and H, just remember it's always from the central angle there at the origin. Okay, so this would be opposite, adjacent, and hypotenuse. I don't care which set of letters you prefer to do your ratios with, as long as you know it correctly. Okay, now they have told us Y or O, whichever way you prefer to think of it, is 12. So this side is 12. And that X or A is 5. Now one of those has to be negative because it says negative right here. Which one is the negative? And how do you know that? Yeah, because we're in quadrant 4. Y is negative. You're going to the right, that's a positive movement. Down, that's a negative movement. Okay, so the 12 is the negative, 5 is positive. Okay, now they're asking for cosine. What's cosine's ratio? A over H, or if you're using X, Y, and R, X over R. So either way, so we know that A or X side, we know that's 5, but we're missing this hypotenuse or R side. You know, two sides of a triangle, how do you find, of a right triangle, how do you find the third? Pythagorean Theorem. Okay, A and B are the legs, C is the hypotenuse. So this is 5 squared plus 12 squared equals R squared, or you can keep it C squared, it doesn't really matter. Okay, notice I just put 12 instead of negative 12. It doesn't matter for Pythagorean Theorem because 12 squared and negative 12 squared come out positive either way, because a negative squared is positive, right? So you don't have to worry in Pythagorean Theorem about including that negative. Okay, so this is going to come out to, so we've got 25 and 144 is 169. The square root of 169 is 13. The side is 13. So now I can answer the question, cosine is 5 over 13. That didn't ask for all 6, just asked for cosine. The beginning of your review, you know, you had those few that said find all 6. There's a similar process of doing Pythagorean theorem, finding the missing side, and then giving all the ratios. And sometimes you have to reduce if it's a radical, or simplify, or rationalize. Okay, this one was a little simpler, and it was only finding one of them. A test question is only going to ask for one of the trig functions. It's not going to ask you to find all 6. On the review, we're having you practice finding all 6 because you don't know which of the 6 it's going to ask for. You need to be able to answer any of them. Does that make sense? Okay. All right, 20, another one that says let theta be an acute angle. Where does an acute angle reside? What quadrant? What's acute mean? Less than 90. What quadrant is that? Quadrant 1. So telling you it's an acute angle, there was another problem earlier that told you it was an acute angle. That's telling you that it's quadrant 1. Okay, so the angle is in quadrant 1, which means what about your positive or negative values? They're all going to be positive. So we know we have positive answers. So if you have any answer choices that are negative, get rid of those. You can eliminate them. Okay. Now they're asking, given cosine, find secant. Well, hello. What are those two's relationship? Not opposite. They're flipped. They are the reciprocal functions. We didn't even have to get through all that. It's literally just the reciprocal. So what is it? Just flip it. You've got to know which functions are reciprocals of each other. Cosine is secant, sine is cosecant, tangent is cotangent. Okay? You got to know those reciprocals because there may be just a simple one where it's just, oh, I know that one. I don't even have to find the third side. Right? All right, 21 gives us the drawing of a right triangle and says to find the exact values of sine and cosine of theta. Okay, so here's theta. Okay, well, we know sine and cosine would be O over H and A over H, right? So from theta, this is opposite, this is adjacent, and this is hypotenuse. I have to know the hypotenuse for both of these. I have to find it. How do I find it? Pythagorean theorem. Okay, so the legs are 5 squared and 5 root 3 squared. This is where this one's going to be tricky and mess some people up. This is all to be squared, not just the square root of 3 gets squared. The whole term gets squared. Be careful. When you square something, these are being multiplied, right? 5 times root 3. So the 5 gets squared and the square root of 3 gets squared. That's what's happening here. Y'all follow that? What's 5 squared? What's root 3 squared? It's just 3. The square root and the square cancel each other out. But it's still 25 times 3, which is 75. 5 squared over here, 25. 25 plus 75 is 100. And what's the square root of 100? 10. So now that I know H, I can give these ratios. So opposite over hypotenuse, that'd be 5 over 10. That reduces. What does that reduce to? Cosine is adjacent over hypotenuse. That reduces. So it's root 3 over 2. It's 5 over 10 reduces to 1 over 2. Y'all agree? If sine is 1, that's all of the questions asking. Those are your answers. But let me just think about this for a second. If sine is 1/2 and cosine is root 3 over 2, those should look very familiar to you. What's that angle? Where is cosine square root of 3 over 2 and sine 1/2? That's a 30-degree angle. Okay, they didn't ask that. I'm just having you think about the numbers. You should recognize those numbers from the unit circle. So far, so good? Okay. All right, so now we're getting into the right triangle trig review. This is the part of the test, these types of questions that you need a calculator for, okay? The calculator will be activated in the test, okay? So you'll be able to open it whenever you need it for these types of questions. Okay, so this goes back to part 1 and part 2 of our Unit 1 notes. We are looking for, in this one, B. So angle B here. So from B, this unknown side is opposite, 4 is adjacent, and 5 is the hypotenuse. Okay, so what I am looking for is the angle that's missing. So I have to use the 2 known sides. So that's the adjacent and the hypotenuse. What trig function puts A and H together? Cosine. Cosine of an angle is A over H, and you plug in what you know. I know 4 and 5. How do I find the missing angle? When the angle is missing, I do what? Inverse trig. So cosine comes over here as inverse cosine of 4 over 5. Now, we are talking about the angles in a triangle. What do we measure those in? What unit of measure? Degrees. So you do need to make sure the calculator is in degree mode. Okay, for a graphing calculator, this is what that looks like. The calculator in Aware for the test is similar. It looks like the Desmos scientific calculator. It's similar to that. So I can pull that up and show you if you need me to. But so that inverse cosine, so second cosine of 4 over 5. So this is the approximate answer. Did they say what to round to? It did not. So for an angle, we'll just round to the nearest degree. And for sides, we'll go to hundredths, I guess. Okay, so I'm going to copy that over onto here. You can see what we got in the calculator. So that is going to be approximately 37 degrees, right? That's that angle B, approximately. All right, in number 23, they're asking us to find H, okay? I don't know why they've got so many letters in here instead of, so how many degrees is this angle? This is what we're looking for. So from there, this is 15 is opposite and the 17 is adjacent. It's the angle that's missing. So I have to use the 2 known sides. I don't even have to label hypotenuse because I don't know it. I know 17 and 15, which is O and A. Okay, so what trig function puts O and A together? O over A. And I end up in the same boat here where it's the angle that's missing. So to get theta by itself, I have to do inverse trig. Excuse me. So inverse tangent of 15 over 17. Oh my gosh, I'm not even paying attention to my screen. It was on y equals. All right, try that again. Inverse tangent of 15 over 17. So if we're rounding to the nearest degree, what is that? 41 degrees. Good. Okay, so when it's the angle that's missing, we do inverse trig. Everybody's good? All right, now on these, it's a side length that they're looking for. Okay, so we're not missing the angle anymore. We're looking for side ST right here. This is what we're missing. I'm gonna call it X. Okay, so from the marked acute angle, 36 degrees, 5.1 is the opposite, is the adjacent, and this that we're looking for is the hypotenuse. So we obviously have to use the hypotenuse because that's what the question's asking for. And then we have to use the known side. So O and H, what trig function? Sine of an angle is opposite over hypotenuse. Now when I plug in what I know the angle, that's 36. It's the denominator that I'm missing. When it's the denominator that's missing, what do we end up doing? Divide, denominator divide. Remember, these two just end up switching spots, the sine of 36 and the x. So x is 5.1 divided by sine of 36. Now, when it's a side length, we typically will round to the hundredths, even though it doesn't say here. That's what we'll go ahead and do. So if I'm going to the hundredths place, this is going to be 8.68, because that 6 is going to round that 7 up. So 8.68, and this was in kilometers. All right, this time, 25, EF is our missing piece we want to find. From the marked acute angle, that is opposite. 31 is adjacent. Here's the hypotenuse. So we have to use what we're looking for and what we know. So that's O and A. So again, that is O and A. O and H is sine. O and A is tangent. So when you plug in your known values, the angle is 72. Opposite is the unknown. 31 is known. So this time we're missing the numerator. So when the denominator was missing, we ended up dividing. When the numerator is missing, we multiply. You're just multiplying that 31 over to the other side. So 31 times tangent of 72. If I'm rounding to hundredths, what does this one come out to? 95.41. Good, that 8 rounds that 0 up. And this was in yards. All right, so far so good? All right, now this gets into, it's still right triangle trig, but it's the application, the word problem. This is like the writing assignment you had yesterday, where you had to explain in words how you go about solving. Okay, so when we do these, we always want to first draw a picture. Okay, make sure we get it labeled correctly according to what's given. And then we will label, okay, what's O, A, and H. And then we will determine what trig function we're using and solve it. And then go back and see, is there anything additional we have to do besides the evaluating the trig equation? Okay, sometimes there's something extra at the end. Okay, so in this case, we have a flagpole. I'm going to sketch us a picture. It's going to be beautiful. Okay, we have the ground. I'll make it green, it's grass. Okay, so on the flagpole, there is a flag that is 4.1 feet tall. And it says that the pole extends 1 foot above the flag. So the top of the pole here is 1 foot above where the flag goes. So here's the flag flying on the pole. And the pole goes up a little bit above the flag. Is everybody okay with that? Now you have two options because they gave you two pieces of information here. They said that the angle of elevation to the top of the flag is 47.1. So from this 24 feet away to the top of the flag would be there, right? Or they said the angle of elevation to the bottom is 42.1. So your other option was to draw this to the bottom of the flag, and the angle's a little bit smaller. Y'all see that? That's what all those numbers are telling you. You get to pick which one you want to use. The difference is the flag itself is 4.1, and this little piece here is 1, right? So if you used the blue hypotenuse, you did it to the bottom of the flag. When you find this opposite side of this angle, you're only finding the pole up to here. So what are you going to have to do afterward? If you know the length of the pole up to here, what are you going to do? You have to add the 4.1 and the 1, right? To get the total height of the pole. If you go and use the pink hypotenuse, you use the angle to the top of the flag, the 4.1 is already included in that opposite side, right? So at the end, you only have to add in that little 1 foot. Y'all understand the difference? It doesn't matter which one you use, as long as you add the correct amount at the end, you'll end up with the same answer. Okay, so I will just use the pink one because then I just have to add a 1. Does that make sense? Okay, so the angle for the pink one, we said, put that in pink, is 47.1. This is 24 from a point 24 feet away, and this is what we're looking for. So from that angle, this is opposite and adjacent. So I'm going to use tangent. It's the numerator that's missing once I get everything plugged in. So I multiply. So 24 times tangent of 47.1. So 25.83 but I have to add that 1 in. And those were all measured in feet. Does anybody want me? Actually, I will in case somebody not in here wants to see it. If I were to do the blue one, this angle is the 42.1. And it's the same opposite and adjacent. I would have set up tangent of 42.1 is x over 24, which I would have multiplied the 24 over the 24 tangent of 42.1. So that would have come out to 21.69. If I'm rounding, the decimal might be slightly off, but then I would have to add in this as well. So I would have had to been adding in 5.1, which comes out to 26.7. So pretty close. It's because we rounded, you know, and this 4.1 may be rounded. Those angles were rounded to the 10th. So that's why the decimal is slightly off, but you would be able to get the close enough answer. It's approximately 27 feet, right? Huh? It'd be multiple choice. So you'll see the closest answer. Are y'all okay with that? So understand the difference? So that one was confusing a lot of people because there were multiple angles given. And you just have to interpret. You have to draw the picture, understand what they're trying to show you there. Okay? All right. To find the height of a pole, a surveyor moves 90 feet away from the base of the pole, and then from an eye level height of 5.5 feet, measures the angle of elevation to the top of the pole, to be 46. Let's sketch out what's happening. So we have a pole. Here's the ground. There is a surveyor standing over here. Little dude. Guess I should give him legs. Okay. And a head, probably. Okay. So it says from an eye level height. That's his eye level. From there to the top of the pole, the angle of elevation is 46 degrees. He is right here, the eye level, 5.5 feet. So that means this little piece right here is 5.5 feet, right? Okay. He's 90 feet away. What is the height of the pole? I'm going to look for the opposite side here, knowing the adjacent side. That's tangent. Opposite is unknown, adjacent is 90. So the numerator is missing, we multiply. So 90 times tangent of 46. So that is here to here. Just this piece. What do I need to do to that? Add the 5.5. Now it does say rounds to the nearest foot. So even though that would round to 0.2, so 0.2 and 0.5, that's 0.7. So that is 98.7. That's going to round to 99. Y'all okay? Okay. Last one, I believe, right? All right, so the base of a cliff 800 meters high is 1,000 meters from the base of a log cabin. What is the angle of depression from the top of the cliff to the base of the log cabin? Okay, so I'm going to sketch this out. Okay, so we've got the ground. Okay, over here is a cliff. Okay, this is the top of the cliff here. And over here is my crooked log cabin. So far, so good. It says that the base of the cliff, this is the base of the cliff, is the cliff is 800 meters high. So this is 800. The base of the cliff is 1,000 meters from the base of the log cabin. So this is 1,000. What is the angle of depression from the top of the cliff? Remember, angle of depression is measured from the horizontal, right? So this imaginary horizontal line from the cliff to the cabin, the angle of depression is actually outside this little triangle that we created. So this is what we're looking for. What did we talk about with angle of depression and angle of elevation? We said the angle of depression and the angle of elevation are what? They're the same, they're congruent. So in the triangle, it's this angle we're looking for, right? Okay, so from that angle, the 800 is opposite, the 1,000 is adjacent, another tangent problem. The angle is the unknown. So we are going to do inverse tangent. Remember, when you have a fraction like this, you can reduce it. You could reduce it to 80 over 100 or 8 over 10 or 4 over 5. It doesn't matter. Or you can leave it as is. As long as you reduce it correctly, that's fine. You'll get the same answer. If you don't want to risk it, don't reduce it. Use the entire numbers that you were given. So inverse tangent, so second tangent of 800 over 1,000. It's an angle, so we're just going to round to the nearest whole number, the nearest degree. So that's going to round to approximately 39 degrees. Now follow? Okay. So again, I'm going to give you the completed unit circle. It's going to look like this. It's going to have everything all filled out, ready to go. But for a lot of the questions that require the unit circle, you're going to need to know how to find the angle, positive direction, negative direction, X is cosine, Y is sine, all that good stuff. Okay. The test is going to be online on Aware. So you do need to bring your laptops fully charged, or at least bring the charger in case it is low. And and you'll get the unit circle, and you'll get a piece of paper to use to do your work on that you'll turn in with it. Okay, let me stop this recording.